All right, let's talk about one of the unsung heroes of network security, the Access Control List, or ACL for short. Honestly, the best way to think about it, it's like your network's very own super strict digital bouncer.
So, picture this, a network with zero rules, a total digital free-for-all. Every single piece of data is just zipping around everywhere, all at the same time. It'd be complete and utter chaos, right? So how in the world do you bring some order to that mess? How do you make sure the right traffic actually gets to the right place?
Well, that's where the access control list comes in. At its heart, an ACL is really just a simple rule book for your router. It's what the router looks at to decide, hey, is this data packet welcome? Or, no, you're not on the list. It's literally a bouncer with a very, very specific guest list.
Okay, so we have this digital bouncer, but how does it actually read its rule book? How does it make those split-second decisions? Well, it turns out the logic is really simple. It's sequential, and man, is it strict.
It's basically a three-step dance. First, the router starts reading the list of rules from the very top. Second, the instant, and I mean the very second, it finds a rule that matches the data packet, it stops. That's the key right there. It doesn't bother looking at any other rules. It just stops, takes action, either permit or deny, and boom, it's on to the next packet. Job done.
But what if a data packet gets all the way to the bottom of the list and nothing, not a single rule you've written matches? What happens then? Well, this is where a supercritical, kind of invisible rule kicks in. It's a rule that's lurking at the end of every single ACL, whether you put it there or not.
And that brings us to the golden rule of ACLs. If you don't explicitly permit a packet, it's always going to be denied. It's what we call the implicit deny. It's the default security setting for any ACL. Think of it this way: no invitation, no entry. End of story.
Now, just like in real life, not all bouncers are the same, right? You've got the guy at the front door who's just kind of glancing at IDs. Then you've got the elite security detail, the one who knows exactly who you are, where you're supposed to be going, and what your business is. Well, ACLs work the same way.
On one hand, you've got your standard ACLs. These are your simple bouncers. They only care about one thing. Where is this traffic coming from? That's it. On the other hand, you have the extended ACLs. These are the elite guards. They check everything: the source, the destination, and the intention. You know, is it for web browsing, a file transfer? And this huge difference is absolutely crucial for figuring out where you should put them on your network. So let's talk about the standard ACLs first. Since they only check the source, they're not very bright. Imagine you put this simple bouncer at the main entrance to a huge building. He might accidentally block someone from getting to, say, the public cafeteria just because of where they came from. That's why the rule of thumb is to place these guys as close to the destination as possible. You put the bouncer for the VIP room right at the door to the VIP room. Makes sense, right?
Extended ACLs, though, they're way smarter. Because they can check the source, the destination, and the purpose, you actually want to put them as close to the source as you can. This is your elite guard, and you want them at the main entrance. Why? Because they can spot unwanted traffic right away and stop it dead in its tracks. This saves a ton of network resources, because you're not letting that bad traffic travel all the way across your network just to get blocked at the very end. It's just so much more efficient.
Okay, so that's the theory. Let's make this real. Let's see how one of these elite guards, an extended ACL, actually works in a real-world scenario.
All right, here's the job. We have a user on PC 1, and we want them to be able to access a web server for pretty much anything. File transfers, you name it. Except, we absolutely do not want them browsing websites on that server. This needs surgical precision. It's the perfect job for our elite guard, the extended ACL.
So here's what the router's thinking. It looks at rule number 10 first. It asks, okay, is this traffic from PC1? Is it going to the web server, and is it for web browsing? If the answer to all three is yes, bam, the packet is denied, process over. But what if the traffic is from PC1 but it's for, say, a file transfer? Well, Rule 10 doesn't match, so the router moves on to Rule 20. Rule 20 says permit everything else. That's a match, so the packet gets a green light and goes through.
So we've seen our digital bouncers and their little rule books in action. It's kind of cool, but why does this all matter? What's the big deal? What's the real-world impact of getting this right? Oh, the benefits are huge. For starters, you get a big performance boost by just stopping unnecessary traffic from clogging up your network. You also get this amazing fine-grained control over traffic flow. But the big one, of course, is security. ACLs are a foundational layer of protection, your first line of defense. And get this, the whole logic behind ACLs, it's the core concept that things like much more advanced firewalls are built on. You know, when you really boil it all down, it comes back to this. These simple little permit and deny lists are the absolute bedrock of how we manage and secure our networks today. They're what bring order to the chaos, what make communication efficient, and what give us that crucial first wall of security. So yeah, these digital bouncers are powerful. They're absolutely essential. But in today's world with cyber threats getting more and more sophisticated, what happens when just checking a guest list isn't enough? What comes next? Well, that's a story for another day. Thanks for joining me.